This is Kent, December 22nd, 2017, and today we tested the Internet Accelerometer on the shake table at EERF. On the outside, the Internet Accelerometer doesn't look like much. It's a nice waterproof box that's meant to be deployed in the field and survive for a long time. It is IP67, and so is the single plug that carries power and Ethernet to the box and charges the battery. If we open the box, inside we find the battery and a UPS/system manager, cooling, climate control, battery protector, little Linux machine, and a tetraseismometer down in the bottom right corner. The battery management unit sits on top of a 12-volt battery. It charges the battery from a power over Ethernet cable that could end in a power supply or in a solar panel. It makes sure the battery is not overcharged and it's not undercharged either. If it gets to 10.5 volts, it'll completely shut it off. This enables the battery to live for at least 7 years. Further, the system management unit has several sensors on board measuring temperature, humidity, etc. inside, from which it can decide whether to turn the Linux machine on or off and whether to turn the fan on in extreme hot situations. Further, it has a real-time clock and 3 levels of watchdog timers that will make sure that the instrument keeps on running, if necessary, taking the power away from the Linux machine and reapplying it after a pause. The built-in tetraseismometer records the waveform and then it applies some math to it. In this case, it is the formulas required by the Ministry of Transportation and Infrastructure in British Columbia. On the right side of the screen, the required parameters are shown, and they are also sent to the server and can serve as a warning for earthquakes. Immediately an event is happening, the server receives a message that the instrument is triggered, and then when the event is done, it'll get an information about how strong the event was and what impact it might have on buildings. The KSI value is a damage index that can be used to assess damage on bridges and infrastructure, as well as buildings. At the end of the event, the instrument tells the server the peak ground acceleration, here 10,422 millimeters per second, which is a bit over 1 g. The peak ground velocity of this earthquake was 7 meters per second. And finally, the maximum displacement, which is of consequence for a building, is 7.4 centimeters, 74 millimeters. The server will then decide whether to receive the raw data in the form of the standard mini-seed files via a secure connection to the instrument. And here we are in the lab control room looking at the raw waveform from the instrument, which is sitting down on the shake table. And we happen to be here at the lab with my laptop looking at everything via TeamViewer. And outside we can see the shake table, a structure meant to destroy, with an Internet accelerometer in the middle that we connect to, and a cable going over to the Ethernet plug in the wall. Connection to read raw files, and events coming in telling us when events start and how big they were when they end are ready, and we are able to look at that as the experiment is rolling. We can also see that new files are coming in every 5 minutes, as they should, and they contain the data from the accelerometer. The shake table sits still, and these numbers represent the noise from the hydraulics and whatever else is going on in the building and out on the road. And we're ready for the first X direction only shake. Which corresponds to the blue graph here. And we marked an event. You can see the mini-seed files are coming in.
You can see the things, right? Yeah.
Oh yeah. We're at KSI of 243 now. That's a big one. KSE I-755. Peak ground acceleration. Yeah, that's a big one here. And we're holding event mode nicely and assesses an S wave. Certainly isn't vertical. So 43 millimeter displacement. Here comes now we're up to 10 centimeter, 14 centimeter. That's probably correct. So this earthquake has peaked. It reached 13.8 meters per second, which is 1.4 G. We were actually running it at 200% magnification. Maximum velocity 6.35 meters per second. And the displacement was about 14 centimeters, 140 millimeters, which we can go and see on the shake table. It's still moving, and the KSI is a matter of how much the building would have been damaged by a simple model that we use directly in the instrument. Let's go see. That seemed to be it. And we're now quieting down. And then we have a post roll of at least 10 seconds, which can be set. And then we should exit event mode. It just triggered again this second. And there's the parameters for the event, and that looks correct. So that is the syslog message, and it was just a minor event. So that last one here. Okay.
Okay, so you want to run continuous, or you want to run next one now?
Yeah, you can go. Present time to trigger. There we go. That made us go into event mode. I can just check on the other machine we got here.
100%.
At 100%. So this is the real thing. There comes the P wave. Now comes the S wave. Not as strong this time as the last one, but in all three directions. North, east, and up. The three colors here. And we can see the peak ground acceleration is only about 1/3 of a G so far. Now we're at half a G. So we're adding quite a bit of load to it. And there was the peak of the earthquake. 10 meters per second, a bit over 1 G. See, that was not anything near the other one. I am suspecting we're going to see some real action in a moment. And that was it. We got our maximum values recorded, and when the event detriggers, it'll send everything to the server. And the table is coming down. the earthquake is over, apart from the little shakings. We notice that the values are now transferred over to the syslog server, and we have 23 seconds of earthquake going on here between the two event timestamps. And as this was going on invisibly, the data was also sent to the earthquake early warning network, and could have triggered alarms in the schools. And we are now back to quiet, and this little unit here will form the backbone of the earthquake early warning network, as well as infrastructure monitoring. And I must say that this test today went without a glitch, so now it's just making some more of them while we wait for the next little what was that? Surprise earthquake. Be safe out there.